Hi everyone, my name is Andrew Chabot, and today I will be demoing the SHA2 256-bit visualization created in the hash function visualization language, or HFVL. So this file, uh, this window has appeared here by running the hfvl.py file and typing in simply SHA2 from the example files in the repository. It took about 5 to 7 seconds to load this file, mainly because of the pathfinding. You can see here a lot of these arrows are close to overlapping, and it's a little bit difficult for them to find the correct area to go. All right, so let's get started by just looking at the overall design of the SHA2 visualization here. So similar to the SHA1 video, if you've seen that video, we have the words for the round 0 in this case up top, and for SHA2 there will be 8 of these words. So we call those words A through words H. At the bottom here we have the words for the previous, the next round. So this is word A through word H for round 1. So the whole point of this is that we're going to be moving from word A round 0 to word A round 1, and the process will repeat itself in a round-like manner. So if we look at these here, these boxes are the addition modulo 2 to the 32nd boxes. They have a bit of a different style from SHA1, mostly just based on the space that we have in these boxes here. There's a lot less space for all these boxes in SHA2 versus SHA1, simply because there's more operations happening in SHA2 versus SHA1. Just like SHA1, we have our boxes for round constant and message schedule here, as well as a description of events box below it to give us more context of what's going on. All right, so let's get into it. Let's play forward a few frames here. You can see that we're first populating these values up top, and let's stop it there. And this is also very similar to SHA1, how many of the boxes up top here are immediately populating the boxes down here. So they're shifting over one for word A, B, and C are going to B, C, and D, and words E, F, and G are populating G, G, H, and no, F, G, and H down here. So we're just transferring those values, hence the blue coloring here. All right, so next we're going to take in these 3 words here into the CH function. The CH, the MA, and these sum 1 and sum 2s are kind of in a similar style to the F function in SHA1. And these are all sub-visualized separately. So let's open up the CH function, see what's going on there. All right, so we have the E and F, and we're going to do an AND here to get E and G, and we're taking the not of E and G, and we're ANDing them together to get not E and G, and then we'll XOR these together to get the output bytes. So we can just play through that, speed it up just a little bit, so we can see this process actually happening. So first we're just translating them into bits to make the operations more clear, ANDing them together to get this value here. And then we're taking the not of E, getting there, and you can see it's transitioning through the function as expected. And then finally we translate our output bits back into output bytes and get this value here. All right, so that's the CH function, and you can see this box gets updated here. SHA2, because of the space constraints we talked about before, instead of having an output box for the CH to go to, the design decision here was that the box for CH needed to turn into the output value afterwards. All right, so moving into populating our round constant and message schedule, you can see when these get populated, the boxes that tell us our current round constants and message schedule also get highlighted here. So just to make the movement, where the values are being transferred from a little bit more clear. So we'll populate those values in, and we'll do addition modulo 2 to the 32nd. So we can just look at this. This is essentially identical to previous addition mod 2 to the 32nd boxes, but we might as well run through it once just to see. So we take this input, translate them to bits. These are going to be added together, and you see we have an overflow here of 1 bit at the beginning. We will take the modulo of this and get the output here. And we just translate this into output byte to get that result. So now we have this result here. Now that we have that, we're actually going to take all 3 of these input words and add these together. I'll show this just because it's a little bit different than the previous addition modulo to the 32nd. So here we have the bytes being translated to bits as per usual, and we're adding them together to get the CH plus H. We take the modulo of this to get this result here. We'll also take in the output from our previous addition to get the bits here. We'll be adding that together with our output from CH plus H to get our overall addition here. And again, we'll be taking that modulo to the 32nd and get our output bits, which will eventually be transferred into output bytes. So we'll run through this really quick. And you can see for both of these additions, actually, the modulo 2 to the 32nd didn't change anything since there was no overflow. Next, we'll be running this word in with the sum1 function. You can see this output value that we get, but let's see how we generate this output value. So the sum1 function deals a lot with bit shifting to the right. We will populate all of these boxes with the bits of the input word E. So we get these values here, and we're going to be shifting shifting all of these values, but by different shift amounts for each. So bit shift right 6, you see we get this value. Bit shift right 11, we get this value here. Bit shift 25 down here, and we get this value. Now we XOR all of these together. We're just XORing one by one for simplicity of seeing what's happening with the operation. XOR those together to get this, and then XOR that result with this result here to get our output bits, and this gets translated back into bytes. All right, so that's the sum1 function. And we'll be adding that together with our previous output here to get this result. I'm not going to hop into any more addition. The additions that are taking in 2 values are identical, besides obviously the inputs are different to them, but what's happening below with the sub-visualizations is identical. So we'll take the output that we just got from the addition of these 2 boxes, and we'll take word D and add them together, getting this result, and we'll populate word E with that. So now we have every word populated here besides word A. All right, so next step, we take in words A, B, and C into MA. You can see the MA function is talked about here in the description, but let's take a look at what happens there. So the MA function will take the AND of A and B, the AND of A and C, and the AND of B and C, and XOR all of those results together. So we can just step through population of bytes to bits, the same pattern that we've had for basically every function visualization. ANDing those together, Anding these two together, we get these results here. Now we can XOR these together and get this result here. All right, next we're doing the AND of B and C. We get this result here. We'll XOR that together with the output that we already had above to get these output bits. And this eventually gets transferred into our output bytes here. All right, you can see this is the value that we have here. And we're adding that together with our previous output. All right, next we're taking word A and applying the sum2 function. So the sum2 function is very similar to the sum1 function. The only thing that is really different is that you'll notice that the right bit shift amounts are changed here. So we're shifting this one up here by 2, this one by 13, and this one by 22. But pretty straightforward in how this is operating. We just bit shift them and XOR them together. So you see we have these three results, XORing that, we get this result, we'll XOR that with our final result, get the output bits and the output bytes. Very similar formula as per usual in these sub-visualizations. All right, so we get this result here. Finally, we'll do our last add of the round here and get this result here. And that will become the result for word A. All right, so now that we've done that, that's the end of SHA2 256 round 0. So now that we're done with that, we are going to take these words and populate them back up here. All right, so we have those up there. We can reset everything back to what it was before, but you can see that we have incremented now and we are on round 1. And all these words at the bottom will become the input for round 2 of SHA2 256. So let's just skip ahead a few rounds using our buttons here. And we'll see on round 4, the current round constant and the message schedule boxes here have updated to show us what the upcoming round constants and expanded words will be. If we keep on moving forwards here, one thing to note is none of these interior functions here, like ch, sum1, ma, or sum2, change in between the rounds like the f function does in SHA1. However, the current round constant is changing for every round, versus in SHA1 it changed only every 20 rounds. So let's just keep on going in between rounds here. For SHA2, there are 64 rounds. Yep, I was right. Okay. So let's just step through round 64 here. Let's play it at a quick speed here. You can see we're repeating the same process that we did before, same order and everything, just to be as clear as possible. And there we have it. That's the end of SHA2 256 bit. So we've run through 64 similar rounds. The overview for the round from the first round stays the same for each round after that, obviously just with updated inputs. So the resulting hash is just the concatenation of these words up top here. And that will be the 256-bit hash based on the message that comes in from the message schedule here. I hope you learned something from this video, and thank you for watching.